Alright, today we're going to figure out empirical formula using percent composition. So we have a molecule or compound with 25.9% nitrogen and 74.1% oxygen. The first thing you have to realize is that this is a ratio. This is saying that for every, let's say what percentage are out of 100, for every 25.9 grams of nitrogen in the molecule, there's 74.1 grams of oxygen in the molecule. It's the same thing as a formula. Let's say we have C4H8. So right now, for every molecule, if you had a million of these molecules, there'd be double the hydrogens that there are the carbons. So that's a ratio. So the first thing we have to do is get the molar ratio. So we have to find how many moles of each one of these elements. So we say there's 25.9 grams of nitrogen times molar mass, 1 mole nitrogen, over 14.01 grams nitrogen. That is equal to 1.85 moles nitrogen. And then we do the same thing for oxygen. We have 74.1 grams oxygen times, I think oxygen, 16.00 grams per mole oxygen. That cancels, don't forget to cancel up here also. Come up with 4.63 moles oxygen. Now, just like I said up here, that it's a ratio, we have a ratio down here which is 1.85 to 4.63. But the next step is that we want this to be a 1 to something ratio. So you'd have to divide by your smaller amount of moles. So you'd have to divide this one by 1.85, smaller amount, divide this one by 1.85, and you should get 1 and 2.5. This is nitrogen, this is oxygen. So now, this is the actual formula right now that we have. We have N1 to O2.5. But in a formula, we need whole numbers. So we have to figure out what to multiply each of these by to get the smallest whole number we can get on each of them. So we multiply by 2 each of them. You come up with N2O5. And that's your answer.